Okay, so now let's do another multiplication, but this time we will essentially make it a little bit more complicated. Okay, so let's say that you have, for example, you have essentially a 3-digit number. So here we had essentially a 3-digit number and a 1-digit number multiplied together. In this calculation, we will get essentially 354, for example, as a 3-digit number, and a 2-digit number, like for example a 23, and we want to do this calculation. Okay, so how do we do that? So again, basically, essentially we have, so that's 354 times basically 23. I'm going to write this down in such a way that we can see essentially 300 and then a 50 and then a 4, and we know that basically, and then we want to multiply it by essentially 23, and that is multiplication. And we know that essentially that this place value is essentially the ones place value, this is the tens place value, and this is the hundreds place value, right? So how do we do this calculation? So first of all, we are going to keep essentially our strategy, meaning that the 354 is nothing but essentially a 300 and a 50 and a 4, essentially put together. A 354, basically a 354 is nothing but a 300 plus a 50 plus a 4, which is essentially nothing but essentially 3 times 100, that's the hundreds place value, plus 5 times basically a 10, which is the tens place value, plus 4 times a 1, which is essentially the ones place value. So 3 times 100 is 300, 5 times a 10 is 50, 4 times 1 is 4. So we will essentially do this calculation by whatever the number is that we want to multiply it by this number. This number is actually 3 numbers essentially put together. It's a 300 plus a 50 plus a 4. So to make things simpler, I'm going to multiply this number first by essentially by the first part of this, then the second part of this, then the third part of this, right? Yeah, but essentially here things are a little bit more advanced, meaning that essentially the number that I want to calculate, that I want to multiply by this number, in and of itself is again 2 numbers in 1 number, meaning that essentially 23 is essentially 20 plus a 3, which is essentially 2 times 10 plus, for example, 3 times 1, right? So actually what I'm doing is that first I have to, essentially these are 2 numbers, so first I have to multiply the first number by this whole number, meaning the first number has to be multiplied by these 3 numbers, and then I have to multiply the second number again by all of these numbers, meaning that the second number has to be multiplied by all of these numbers. And then if essentially if we added the whole thing back together, we should get our essentially the total number basically, okay? Now in order essentially to see how this works, I'm going to actually write down the numbers this way. I'm going to say that essentially a 354 plus a 23 is essentially nothing but essentially a 354, which is a 300 plus a 50 plus a 4, and you want to multiply that, you wanted to multiply, and you want to multiply that by this number, which is essentially a 20 plus a 3, right? Now this calculation essentially becomes, this calculation over here essentially becomes this first number multiplied by each and every part of the second number, and then also the second number multiplied by each and every part of this number again. So the first number 20, so that's essentially 20 times a 300 plus a 20 times plus essentially a 20 times a 50 plus a 20 times a 4. And then you essentially you add this to and then you add this to basically the 3. Let me write the 3 with this color. So then I'm going to use another color. So let's say that this is the 3, and then plus the 3 times basically the 300 plus the 3 times essentially the 50 plus the 3 times essentially the 4, right? Now let's see what this calculation is. 20 times the 300 is 6,000. 20 times 50 is equal to 1,000. 20 times 4 is equal to an 80. And then basically 3 times the 300 is a 900. 3 times 50 is equal to 150. And 3 times 4 is equal to 12. Now we can add all of these numbers together. 6,000 plus 1,000 is 7,000. And basically 900 and 150 is 1,050. And 80 plus 12 is 92. These two put together would be 92. And then if you add these numbers together, 7,000 and 1,050 is 8,050, and plus a 92, which would be essentially a 14 and 8,142. So, and if you do this calculation essentially on a calculator, you have 354 by 23. 354 times at 23 is the same thing as 8,142. 8,142. So what we are about to do is supposed to work, meaning that essentially you take a look at your first number, you will expand it, take a look at the second number, you expand it, and then basically for example, this number has 2 parts. You take the first part and multiply it by every part of the other number, and then you add that to essentially the second part of this number multiplied by every part of this number, add the whole thing together, you will get essentially the sum, which is 8,142, right? So we will do exactly that, but then you see that this gets a little bit complicated, right? So how can we simplify it a little bit? So we will essentially use now the algorithm in order to simplify everything as much as possible. So then what I'm going to do is that now basically the second number, which is a 23, it has basically 2 parts. It's a 20 and a 3, and we saw that essentially we take essentially every part of this number multiplied by every other part of the other number. So one part of this, one part of 23 is a 3. So I start with the 3. Okay, if we do so, we will essentially have this thing over here. Let me erase these. Okay, so now we have basically, if I start with the 3, we will have essentially 3 times of 4, right? So you multiply 3 by the 4, by the 5, by the 3, and then the same essentially you will do with the 2 times the 4 times the 5 times the 3. So 3 times the 4 is essentially a 12, right? 3 times the 4 is equal to 12, and basically I cannot write a 12 over here, right? Because essentially in the ones place value you can have essentially only one digit. So what I will do is that I will write essentially the 2 over here, and essentially a 12 is a 10 plus a 2, right? So the 2 I have already written, so I keep the 10 so that I can I can essentially add it back into the number, right? So this 10 essentially remains. Now this essentially then again the 3 times of 5 basically, which is equal to 15, but then this is 3 times essentially a 50, because essentially this 5 is in the tens place value, and so 3 times 50 is essentially 150, right? And 150 plus a 10, essentially we have a 10 over here, so that becomes essentially 160. Now the 160, if I put a 6 over here in the tens place value, it becomes basically it becomes essentially a 60, because 6 times 10 is equal to 60. So if 160 is essentially 100 plus 60, the 60 part is taking care of, the 100 part remains. And the 100 part, of course, we have to add it back essentially to the number basically. Now the next part is 3 times 3, but then essentially the second 3 over here is actually a 300, because essentially that's in the hundreds place value. 3 times a 300 essentially is a 900, and then we have also 100 over here. So a 900 plus 100 essentially is 1000. So I'm going to essentially add a new place value to the number, meaning I'm going to add essentially 1000's place value to the number and put a 1 over here. So 1 times 1000 essentially is 1000. So then this 1000 is taken care of, so we can get rid of essentially all of this basically. Now, and of course over here I need to add a 0, because we said essentially 3 times a 300. We said 3 times a 300, which is essentially 900. And then from before we had essentially 100 hanging in the air, so essentially 100. So we got 1000. We put a 1 over here for the 1000, and of course since there is nothing to add over here, I just simply put a 0 over here to just fill the place value, right? Now let me check over here. 3 times equal to 12, 1, 15, 16, 1, 9, 10. So we have no problem so far. Now for the second part, we will multiply this 2 by each and every one of these numbers, meaning by the 4, by the 50, and by the 300. So then 2 times essentially a 4, we have essentially 2 times a 4, which is actually a 20 times basically a 4, because this 2 essentially is in the tens place value, and so that becomes essentially a 20, and then basically this 4 is of course just a 4, right, which is equal to 80. 20 times 4 is equal to 80. So if I put an 8 over here in the tens place value, 8 times a 10 is equal to 80, so this whole thing is taken care of, right? And you see that essentially this place value remains empty because there is nothing to put in this place value, and it always essentially remains empty in the second row basically, because essentially even if you had a, suppose that basically you had a I mean the least amount that you can calculate here. For example, suppose that I had a 1 over here and a 1 over here, right? A 1, essentially this one would be a 10. 1 times 10 would be a 10. So 10 times 1 would be a 10, right? And the 10, essentially you would have to write a 1 over here to mean essentially a 10, and still this would remain empty, right? And even if I essentially have made everything as large as possible, meaning that essentially if I had a 9 over here plus a 9 over here, so a 9 times a 9 would be essentially an 81, and then times a 10, because essentially the 9 over here would be in the tens place value, so the number would be essentially 810. So for the 810 you would get a 1 over here and an 8 over here. 8 times 100 would be 800, and the 1 over here would be 1 times 10, which is a 10. So in all cases essentially this would remain empty. And for the same reason, essentially when children go to school, their teacher tells them that essentially in the second row, first put a 0 over here and then do the rest of the calculation. Then for the next row, then put 2 zeros at first and then do the rest of the calculation. Then for the next row, then put 3 zeros and then do the rest of the calculation, because these essentially these few place values in the second and the third and the fourth row, they naturally remain empty basically. Okay, so now that is essentially a 20 times 4 is equal to 80. 2 times basically 2 times a 20, that's a 2 times 5, but then that's actually a 20 times a 50. And you see that essentially you have to remember each and every one of these things when you essentially go through this algorithm, which when we make it essentially simple, then you won't have to remember any of these things really. But for the sake of understanding, of course, you'll have to understand all of these things. So this 2 is in the tens place value, which is a 20. And this 5 is in the tens place value, which is a 50. And this is nothing but essentially 1,000, right? So if I essentially put a for the 1,000, I cannot put it over here. I would have to put it over here, but still some numbers might come over here, so I'm going to just keep the 1,000 and then do the rest of the calculation basically. Okay, so this part 2 and 2 times 5 is already done, and then we have essentially 2 times 3 basically, which is essentially nothing but the 20, because it's in the tens place value, and a 300 because the 3 is in the hundreds place value, right? So then I'm going to say essentially 20 times 300 is the same thing as a 6,000, right? Now we have a 6,000 here and 1,000 from before, which is essentially a 7,000, I put a 7 over here to mean essentially 7,000. And I'm going to fill this with a 0. Right? And again, I'm going to fill this also with a 0 to not to create any confusion here. And we have already taken care of these. Now we can essentially add these numbers together. So that's a 2, that's a 14, 1 carryover, and then we can bring that down, and then 1 plus 7 is equal to 8. So then the number essentially becomes 8,142, which is essentially the number that we have. Right? Now you saw that essentially doing this calculation was a little bit tricky, meaning that, for example, when you want to calculate essentially this 2 times 5, you have to remember that both of these numbers are in the tens place value. So this is actually a 20, this is actually a 50, and so then it becomes actually 1,000, right? If you make just one mistake, the whole thing, of course, is going to be wrong, right? Now let's make this a little bit simpler, meaning essentially the same 354. I'm going to write this a little bit more neatly. So I'm going to write essentially a 354 times 8, and I was not supposed to write these over here, I apologize. So we have basically a 354, and this is the ones place value, this is the tens place value, this is the hundreds place value, times the 23. You want to multiply, and let's do the multiplication. Now when you understand essentially how to actually do the multiplication, essentially based on the rules and regulations of the decimal number system, and essentially take all of those things into consideration, once you understand those things, then you can make this whole thing simple by just saying that, okay, so we have essentially all of these numbers, and we are just going to keep the rule that every part of the second number has to be multiplied by every part of the first number, meaning that the first number is a 354, which is a 300 plus a 50 plus a 4. So the first number has 3 parts. And the second number is a 23, which has essentially 2 parts, a 20 and a 3. So the 3 has to be multiplied by the 4, by the 50, by the 300. The 20 has to be multiplied by the 4, by the 50, by the 300. And then once you do the multiplication, all of those parts, we will add them together. That becomes essentially the result, right? We will still do that exact same thing, but we don't have to remember essentially what is in the tenths place value or in hundreds place value, as long as you keep your numbers neat and clean, meaning that as long as you write everything in its own column, then everything is automatically going to be taken care of. Meaning that I just simply say 3 times 2 is equal to 12. Keep the 1 over here. 3 times 1 is equal to 15 plus 1 is a 16. So again, keep the 1 over here. 3 times 3 is equal to 9 plus 1 is equal to 10. So I write the 10 over here. And then basically then I put a 0 over here, right? You remember that the 0 that we used over here. I put the 0 over here, and now we understand essentially why we actually add that 0. And then I say, okay, so that's 2 times 4 is equal to 8. 2 times 4 is equal to 10. 1, keep the 1. 2 times 3 is equal to 6, plus 1 is equal to 7. Right? And then essentially all of these numbers I'm going to add together. So add these numbers together, we will have essentially a 2, 14, 1 remainder, 1 comes here, and 8142, which is exactly the number that we had over here. Okay, so hopefully you have actually learned multiplication, what that actually means, and now we can essentially go back to essentially dividing and multiplying by different factors of 10. So I will see you in the next video, and thank you. Okay, so welcome back. Now in the previous videos we talked about multiplication, division, and now finally we understand them essentially completely. Okay, now we can essentially use those operations like division, multiplication, and also addition and subtraction to do essentially different operations on numbers. Okay? Now in exercises that essentially in the problems that you solve in mathematics, one of the things that you need to be good, essentially that you need to know essentially, is what happens when you essentially multiply by a factor of 10 or divide by a factor of 10, and then you will be able to use these in different places essentially while you're solving a problem basically. Now what happens, so first let's talk a little bit about multiplication. Now what happens when you multiply something by a factor of 10? For example, suppose that you have a 2 and you multiply it by 10, and you know that essentially 2 times a 10 is equal to 20, right? And you see that essentially here, essentially the 2 remains here, and basically essentially when you multiply it by a factor of 10, a 0 is added to the end of the number basically, right? And let's go through essentially what happens actually in the multiplication. So I have essentially a 10, for example, and multiplied by 2, right? So if I do the multiplication, I have essentially 2 times 0 is equal to 0, and 2 times 1 is equal to 2. So essentially you will get your 2 back, but then this time essentially 2 goes to the tens place value, right? There is now a 0 over here, and therefore 2 goes to the tens place value. So initially the value of 2 was just a 1 and 2, and now the value of 2 essentially in the new number essentially becomes a 20, right? In the exact same way, for example, if you have a 3 and multiplied by 10, you will have essentially a 30. If you have a 4 multiplied by 10, you will have a 40, and so on and so forth, right? Now we have essentially all of these smallest n-digit numbers and the greatest n-digit numbers. We have basically the smallest n-digit numbers, and when I say n here, I mean essentially that this n, you could take it as any number, 1, 2, 3, 4, and so on and so forth, meaning the smallest 1-digit number, the smallest 2-digit number, the smallest 3-digit, and so on and so forth. And you know that the smallest, for example, 1-digit number is a 1 basically. The smallest 2-digit number is a 10. The smallest here I'm making the assumption that numbers start from 1, meaning that 0 I'm not taking into consideration. The smallest 2-digit number is a 10. The smallest 3-digit number is 100. The smallest 4-digit number is 1,000. The smallest 5-digit number is 10,000, and so on and so forth, right? Now, in the exact same way that we did the multiplication a few seconds ago, when you multiply essentially these numbers by a factor of 10, again another 0 is added to essentially to the end of the number. Meaning that if you essentially multiply 1 by essentially by 10, you will get a 10. If you multiply a 10 by a 10, essentially you will have a 100. If you have a 100 and multiplied by 10, you will have essentially 1,000. If you have 1,000 multiplied by 10, you will get essentially 10,000. And if you have essentially for example, 10,000 multiplied by 10, you will have essentially 100,000. And well, it just keeps going, right? And let's do essentially one example over here. See essentially what happens when you, for example, when you have 100 and multiplied by 10. When you have 100 and when you essentially multiply this by 10, you will have essentially 0 times, of course you know that 0 times anything is a 0. So the first row would be 0, 0, and 0, right? And then basically we have 1 times 100, which is 100. So you see that essentially this 0 over here, when I essentially move to the second row, of course I have to add the 0 for reasons we saw in the previous videos. And now 1 times, well, 100 is just 100. So your 100 essentially shifts back, basically shifts back 1 place value to the left, which means that now your 100 actually has become 1,000, right? Because of the fact that we have to use a 0 over here, your 100 was essentially a normal 100. When you multiplied by, and then when you multiply by 10, it's essentially shifted back 1 place to the left, 1 place value to the left. Every digit is in the number is shifted essentially one place value to the left. And so as a result, now your 100 is 1,000. So if you add all of these together, you will get 1,000. And so 100, for example, times 10 is 1,000, right? And that's exactly what happens essentially in all of these numbers. We have basically 1 times 10 is 10, 10 times 100 is 10 times 10 is 100, 100 times 10 is 1,000, and so on and so forth, right? Now, so this way essentially now we understand that if a number, any number, is multiplied by a factor of 10, then basically we could say that essentially a 0 is added to the end of the number, basically, or essentially to the end of the number, right? Meaning that, and it doesn't matter what number that is. For example, even if you have 999, if you multiply it by 10, you can just simply add a 0 to the end of the number, and that would be essentially your multiplication. And 999 becomes 9,990, basically. Now, in the exact same way, when you multiply essentially a number by a factor of, let's say, 100, for example. For example, a 1, if you multiply it by 100, you will have essentially 100. If you have essentially a 10 multiplied by 100, you will get essentially 1,000. And here basically you can see that essentially in this number I have no 0. In this number I have 2 zeros. And in this number I have 2 zeros again. Over here, in this number I have 1 0, in this number 2 zeros. And so this number essentially will have 1, 2, and 3 zeros. 1, 3 zeros, that would be essentially 1,000. If you have essentially 100 times, for example, 100, that would be essentially 10,000. So again, I have 2 zeros, 2 zeros, 4 zeros. So this number will have essentially 4 zeros. Okay? So, which means that essentially when you multiply essentially any number by a factor of 100, there is no need to essentially do any sort of calculation. Just add 2 zeros to the end of that number. meaning that, for example, a 99 times 100, you will just simply write your 99 and add 2 zeros to the end of that number. Okay. Now, and then by the same logic, when you multiply a number by a factor of 1,000, 3 zeros are added. By a factor of 10,000, 4 zeros are added. Factor of 100, essentially 100,000, 5 zeros are added, if I'm not mistaken. 100,000, 5 zeros are added, and so on and so forth. So that's essentially how basically multiplying by a factor of 10 or 100 essentially, or whatever essentially works. Now, what happens if you divide something by a factor of 10, or you divide something by a factor of 100, and so on and so forth? Because that happens also in calculations that we do, so we need to know them so that our work becomes essentially easier. So, for example, let's say that you have essentially 1,000. You have 1,000 and you divide it by 10, right? And, well, actually, I'm going to say it also this way, might be more beneficial. So we know that essentially any A divided by any B, if that's equal to C, meaning if you have essentially any number and divided by any other number, and if you will get essentially some C basically. Now the A, B, and C could be essentially any real numbers basically, right? Now this, of course, you know that it implies that A is equal to B times C. For example, if 15 divided by 3 is equal to 5, which implies that 15 is actually equal to 3 times 5. That's a rule, always applies. So then when you divide some number by some other number, you'll get some number C, and then the number which is in the numerator is always equal to the product of these two numbers, meaning product essentially means the multiplication. So A would be equal to the product of B and C, right? So then basically even from this, I can just simply answer this question without essentially doing any division. If I want to know essentially what is 1,000 divided by 100, that's going to be essentially some C over here, right? Or essentially some number B, basically some number, let's call it C, for example. I don't know what that is, we want to find it. Now based on this rule over here, then this number which is in the numerator, this 1,000, must be equal to the product of these two numbers, which is 10 times C basically, right? Now you know that essentially if you have a 10, if you multiply it essentially by a factor of 100, which has 2 zeros, and 10 has 1 zero, and so then you will get 3 zeros, which is what we are looking for. So that's essentially 1,000, which means that essentially the value of C must be 100, right? So the value of C must be 100. So we can say that basically 1,000 is equal to 10 times basically 100. And now if the value of C over here is 100, then what this means is that essentially 1,000 divided by a 10 is equal to 100, right? So, and well, then by the same logic, essentially, for example, I don't know, 100, for example, divided by a 10 would also be essentially a 10, for example, because this numerator is supposed to be the product of these two numbers, the product of this number and this number. Now you know that essentially 10 times 10 is equal to 100, so of course 10 is the correct answer, right? Now what I want to point out here too is that whenever essentially you have for example, like a number like 1,000, and you divide it by a factor of 10, you will always lose 1 0 in the number. In multiplication we used to gain zeros. In division we will lose zeros basically. So 1,000 originally has 3 zeros, but then when you divide it by a factor of 10, now the number will end up having only 2 zeros, right? And also if you have essentially, if your 1,000 over here, let's now divide it by a factor of 100. Now that you're dividing by a factor of 100, because 100 essentially has 2 zeros, then essentially your original number will lose 2 zeros now, which means that essentially now the number becomes a 10. And of course you know that this number in the numerator is supposed to be equal to the product of this number and this number, which means that of course 1,000 is the same thing as 100 times a 10. So the 10 must be the correct answer, right? Now, using what we have learned here, now we can basically essentially simplify fractions. Meaning that suppose that for example we have, I don't know, something like suppose that for example you have this fraction like for example 1920 times 100 divided by 10 times for example, I don't know, 1800, right? If this is your fraction, of course you could, one thing that you could do is that you could just basically multiply everything together, of course, and write this as, for example, 1920 and then add 2 zeros over here for multiplication by 100. And then basically you have 1800 times 10 would be essentially 1800, and then add a 0 because you're multiplying by factor of 10. And then basically if you were to, for example, to do this manually by hand, you would write for example 192,000 and divide that by an 18,000 and essentially do the calculation this way, right? You can do it this way, but you can also simplify your fraction. And to simplify, basically we can what we could do is that you can say that, okay, so we have basically essentially 1920, for example, is the same thing as 192 times 10 basically, right? And then we have 100 over here, and then we have a 10 over here times essentially an 1800. So an 1800 is the same thing as, for example, 18 times 100, right? Now basically what I could do is that I could write this fraction as essentially 192 times a 10, for example, over a 10 times an 18, right? And so that means that essentially I have actually written this part over here and this part over here, and then I multiply this by another fraction containing these two numbers, 100 divided by 100. And of course you know that 100 divided by 100 is just 1, so that's 1, and any number multiplied by 1 is just itself. So we can just simply now write this as 192 times a 10 over a 10 times, for example, 18. And then we can basically write this as basically 192 divided by 18, for example, these two numbers, and then multiply that by basically 10 over here and 10 over here, right? And of course you know that 10 divided by 10 is equal to 1, meaning that actually or you could say that you can simplify the two tens from the numerator and the denominator. So I simplify these two, so this fraction becomes essentially just a 1, right? And now, and of course any number multiplied by 1 is the number itself, so it becomes essentially 192 divided by 18, right? And now you can essentially write, for example, 192 divided by 18, and now this way you can essentially, your operation becomes much easier, much simpler, compared to the essentially to the calculation that we had before, which was, for example, something like this over, I don't know, it was something like this basically. This is essentially 192,000 divided by 18,000. This is just simply 192 divided by 18. Going through this calculation is much simpler now. Okay. So that's basically essentially all about dividing and multiplying by different factors of 10, and also the simplification of fractions. I hope that this video was helpful, and of course it will be helpful in once we get to the exercises in just a few videos, and I will see you in the next video. Thank you. Okay, so welcome back. Now the next thing that we need to learn before we go to the exercises is basically how to solve an equation. So essentially, what do I mean? Essentially, of course, there are many kinds of equations in mathematics, and basically every kind of equation has to be solved based on the type of the equation. But there is, I mean, for now, basically, we essentially need to be able to solve simple sorts of equations, meaning that, for example, you have some number. Let's say that, for example, a 10 times an x, for example, is equal to 20, right? And so essentially we have two numbers, 10 and this x, and then the product, meaning when you multiply them together, you will get the number 20, and you want to know essentially what is the value of x here, right? So this is called an equation. And equation essentially, because you're essentially equating two things basically. Equating means basically that you have essentially you have an equal sign. So you have the equal sign, which is essentially this sign over here. And when you have an equal sign, then you put essentially something on the right hand side, you put something on the left hand side, and these two things are supposed to be equal. And for this, essentially, because essentially these two are supposed to be equal, then you would essentially call it an equation. That's called an equation, right? Now you can think of this as essentially as a balance with two balls basically. So you have something like this. Let's say that this is a balance, and then I have this ball over here, and this ball over here, and I have a thread over here, another thread, and so essentially these two balls, this ball and this ball over here are connected essentially to this rod, and that the rod is connected over here, and this is a rod. And so essentially then you can use this balance in order to weigh different kinds of things, meaning that essentially you put something on this ball and another thing on this ball, and then you can essentially check whether essentially the masses of these two objects are exactly the same. That's called a balance, which is essentially used generally for weighing. But then in case essentially you have the same masses essentially in the two bowls, then this rod is going to be completely horizontal. And once it's horizontal, that means essentially these two masses are the same, meaning the weights are equal basically, right? Now the exact same thing we have essentially with the equation. With the equation, essentially you have this bowl over here, which is essentially this side of the equation. You have the other bowl over here, which is the other side of the equation, and then you have the equal sign, meaning that essentially the weight of these two masses are supposed to be the same, right? And then of course there is basically inequalities. This is called essentially an equation, and then there is also something called inequality. And so based on the name, you can say that essentially the two things are then supposed to be unequal, meaning not equal, right? So then you would say that, for example, 2x plus 3 is equal to 5, but then is not equal to 5. That's called an inequality. Or you would say that, for example, the 2x, for example, plus 3 is greater than, for example, 5. Or you could say that 2x, for example, plus 3 is less than 5. Or you could say that basically 2x plus 3 is greater than or equal to 5 basically. Or you could say 2x plus 3 is less than or equal to 5. These are essentially all different types of inequalities. But then in case essentially you have an equal sign over here, then this is called an equality, or essentially an equation. And so then of course it makes sense that when you have an equation, the two things on the two sides of the equation are supposed to be the same, meaning having the same weight basically, right? Now based on this you can solve essentially equations, right? Based on understanding essentially the nature of an equation, of course you will be able to solve it using the basic operations in mathematics, meaning an equation is always basically solved using the four basic operations: addition, subtraction, multiplication, and division. If you understand these, you can essentially solve any kind of equation, unless the equation is a little bit advanced and needs essentially more advanced tools. But most of the time, essentially using these four operations, you can solve essentially all equations in mathematics. So now how do I solve this equation? So I know that basically that of course, since this is an equation, what I have on this side of the equation is supposed to be equal to essentially what I have on the other side of the equation, right? So now on this side of the equation I have a 20. That means that the value on essentially on the left hand side of the equation is also supposed to be a 20, and that's a 10 times x basically. Now if I try, for example, set x is equal to 1, then I have essentially 10 times x is equal to 10 times 1 is equal to 10. And so this is not the right value for x, because the value of this expression 10 times x is supposed to be equal to 20, and this is 10, so this is not the right thing. Suppose I set this value to, for example, set x is equal to 3, for example, then 10 times x would be equal to 10 times 3, which is equal to 30, which is not equal to 20, right? So this is not the right solution. Now suppose that I set x is equal to 2, for example, then 10 times x would be equal to 10 times 2, which is equal to 20, and then essentially, since I was looking for 20, this is the correct answer and this is the correct value for x, right? Now you see that essentially solving the equation this way, I'm using essentially the method of trial and error. In trial and error, you guess something. You guess that the value of x is going to be, for example, some number, essentially, or close to some number. And then you set the value of x to that number, equal to that number. Test that number in your equation. If that is the key, essentially, if the value of the x that you have chosen, if that works, then that is the solution to your equation. So then essentially this x is equal to 2 is the solution, is essentially the solution to the equation. And you keep, essentially, you have to keep basically trying different values until you get to the solution of the equation. Now this is this equation over here, 10 times x is equal to 20. This is a simple equation which you also can write as 10x. Instead of saying 10 times x, you can say 10x is equal to 20. So I know that essentially a 20 is a 10 times 2, so then basically I can set the value of x to 2 and I can solve the equation. But some equations are a little bit, essentially, are not very straightforward, meaning that, and then if the equation gets a little bit complicated, then you're not going, if you want to choose essentially trial and error, then you will have to essentially set the value of x to many different types of values, and it might take essentially a whole lot of time to come up with the actual solution to the equation. So we need to find essentially a better way to solve these equations. So what can we do? The same equation, basically 10 times x or 10x is equal to 20. If I want to solve it, I can essentially use one of the properties of division, basically. The property of division, and you know that essentially a division is, for example, when you say 15 divided by 3 is equal to 5, this essentially means that a 15 is essentially nothing but essentially the number that you have in the numerator. So this expression over here is actually the same as 15 divided by 3 is equal to 5, right? And you know that this number over here is the numerator, this number over here is the denominator. The number on the top side of the fraction is the numerator, the number on the bottom side of the fraction is the denominator, right? So and of course the meaning of these two expressions are exactly the same. So when you say 15 divided by 3 or 15 thirds, you would read this as 15 thirds, or for example, you would read this as 15 halves, or you would read this as 15 fourths. So that's essentially 15 fourths. This is THS, 15 fourths. Or for example, this is 15 fifths. This is 15 sixths. This is 12 halves. This is 13 thirds. This is 14 sixths, and so on and so forth, right? Now, when you essentially the meaning of these two expressions are the same. Now, if I say 15 thirds is equal to 5, what that means is that from this I can conclude that 15 is actually nothing but 3 times 5, right? which is essentially the same thing as 15 is equal to 5 times 3, right? So then essentially when you have a division, there is this relationship between the division and between the multiplication. Essentially this expression has been written in the form of division. The same expression you can write it in form of a multiplication, right? And the inverse of this is also true, meaning that when you have essentially a 15 is equal to 3 times 5, then from this you can conclude that essentially 15 divided by any of these numbers, for example divided by 3, is the other number, which is 5. Or essentially 15 divided by 5 is equal to 3. Both would be essentially correct statements, right? So in general then we can say that when you have some number a, any real number basically, a could be any real number, and if you divide that by some number b, if that gives you essentially some number c, like this expression over here, then from this we can conclude that essentially that a is nothing but b times c. And we saw over here that the inverse of this is also true, meaning that if I have a is equal to b times c, then that implies, that's called an implication. Implies, that means it has a kind of means that a divided by, for example, by b is equal to c basically. So now you see that I have this expression over here, which is exactly this expression. So these two expressions are exactly the same. And I have this expression over here, which is exactly the same as this expression, right? Essentially. And you see that essentially this expression implies this expression and vice versa. So then I could say that essentially I could put these two together, meaning essentially one of them implies the other and also the other implies the other one. So it's kind of a two-way street, right? So then I can essentially combine these two expressions together, and I can say that if essentially a is equal to b times c, two-way implication, and then a divided by b, for example, is equal to c. This is called two-way implication, and in mathematics, essentially you would essentially read that as if and only if, or you could write it as essentially IFF, if, meaning it's a two-way implication, not a one-way implication. So what this means is that essentially this side implies this side, and also this side implies this side. Okay? So now this essentially this property of this relationship that there is between multiplication and division, we can use it in order to solve our equation, right? So what I'm going to do then is that I'm going to come over here to our equation. Okay, so now basically when we come to our equation, now essentially what we can say, we saw that essentially when you have some number 3 times 5 is equal to 15, then you can say that essentially 15 is when you divide that by any of these two numbers, for example the 5, you will get the other number, which is 3. You can use this essentially you don't have to make it unnecessarily complicated for yourself. I just wanted to essentially introduce a couple of things and make it formal, because sooner or later, of course, we'll have to do this kind of thing in our work here. Okay, so if whenever there is a need, of course you can make things as complicated as as you need to. But then remembering something like this is much easier, right? So then basically, so then essentially based on this, I can say that, and you see that essentially when I have this expression, I take the number which is essentially on the one side of the equation. So on the one side of the equation, I have just one number. On the other side, I have two numbers multiplied together. The number that is essentially alone on one side of the equation goes to the numerator, right? And then in the denominator, you will have either this number or this number. It doesn't make any difference. And then on the other side, you will have essentially the other number. So I will start with, for example, I could write 20 divided by, and I could say divided by 10, or I could say divided by x. So if I write 20 divided by x is equal to the other number, which is equal to 10, this still doesn't let me do anything. I mean, this still doesn't let me solve the equation, because I wanted to actually come up with the number, right? So what I'm going to do is that I'm going to write the other variation, meaning that I'm going to say that 20 has to go to the numerator anyway, but in the denominator I'm going to divide by the 10, and that's equal to the other number, which is equal to x. So we know that essentially 20 divided by 10 is equal to 2, and that way essentially we know that x is equal to 2 basically, right? So this is essentially how you would essentially solve an equation. Now all of these things that we have learned in these 4 or 5 videos, we will put them together to essentially to solve these questions, to solve these exercises, exercise 1.1. So I'll see you in the next video, and thank you. Okay, so now welcome back. So now let's take a look at exercise 1.1. We have essentially these questions over here, which are, for example, 1 lakh is so many 10,000s, or 1 million is so many 100,000s, or 1 crore is so many 10 lakhs, and so on and so forth. Okay? I will do a couple of these. The rest you can, of course, do yourself. So now I just simply want to show you how to go about solving these problems, and then the rest you can practice on your own. So let's see. For example, this is exercise 1.1, and we have question number 1, part A, and we have essentially 1 lakh is equal to so many 10,000. Okay. So now how do you solve this problem? Essentially, any problem that you want to solve, of course, you need to understand it. I mean, if you don't understand the problem itself, you will never be able to essentially to arrive at the solution, right? So in this problem, of course, 10,000 you can understand, and you need to know essentially what 1 lakh is, and essentially based on the definition that we talked about before, basically 1 lakh is essentially nothing but essentially 100,000, right? That's just simply a definition, because in the Indian system of numeration, instead of saying 100,000, we just simply say 1 lakh. So it's just, you just simply need to remember this, right? So then 1 lakh essentially is 100,000. And what this means is that when they say essentially so many 10,000s, what they mean is that it is some number times essentially 10,000, right? So now we have written our problem in in mathematical form, and now it seems that it's actually an equation basically, and we need to solve the equation. So how do you solve this equation? In the previous videos we talked essentially about solving equations, and we saw that essentially, for example, when you have some number like 15, which is equal to 3 times 5, then you can based on this, you can say that essentially this number 15, which is essentially alone on one side of the equation, if you divide this by essentially any one of these two numbers, meaning, for example, suppose you divide by 3, on the other side of the equation you will get the other number, which is 5. Or essentially, if you take the same 15 and then divide by 5, for example, you will get the other number, which is equal to 3, right? So this essentially, this property of essentially, or this relationship that exists between multiplication and division, you can use it essentially in order to solve this problem, because of the fact that essentially, you see over here we have essentially 15 is equal to 3 into 5, and so we have essentially two numbers multiplied together, and again two numbers multiplied together, and then a 15 is another number on the other side of the equation, and then on the other side of the equation essentially we have another number over here. So it's the exact same situation, right? So then what I'm going to do is that I'm going to say that essentially the number which is alone on one side of the equation, I'm going to write it as 100,000, of course, and then divide that by, essentially I could divide by any of these two numbers, but then if I divide by x and then write it as equal to the other number, for example, which is a 10,000, this is not going to help me. Essentially, this is just simply not going to help me, because now what is 100,000 divided by x, right? My goal was to be able to calculate something actually, so this is of course not going to help me. Or if I take essentially the same 100,000 and divide it by, now instead of dividing by x, I'm going to divide by this number, which is 10,000, right? And that is equal to the other number, which is x. So now this way we have actually found the value of x. It's 100,000 divided by 10,000. Now again, in the previous videos we talked about essentially multiplying and dividing by different factors of 10, and whenever essentially you have a calculation like this, which is essentially, for example, x is equal to 100,000 divided by 10,000, you can always look at the number. Essentially, of course, this is provided that your numbers are this type of number, meaning the smallest, for example, 5-digit number, the smallest 6-digit number, meaning the number starts with a 1 and then you have a bunch of zeros in front of the 1. Again, the number starts with a 1, you have a bunch of zeros in front of the 1. So whenever that is the case, you will always look at the number of zeros that your number has in the denominator, meaning essentially the number you're dividing by. And you see that I have 4 zeros over here. And so then, since I'm dividing basically, I will lose the same number of zeros in the number in the numerator. Meaning that if I lose essentially 4 of the zeros here, I will be left with a 10, and then this number of course is a 1. So this whole thing essentially becomes a 10, right? Now if you don't understand this, we can make it a little bit simpler. We can take essentially one more step. We can say that essentially this x is actually simply essentially 100,000 divided by 10,000, and I can rewrite essentially the numbers in the numerator and in the denominator. Instead of 100,000, I'm going to write 10 times a 10,000. And, well, I have a 10,000 in the denominator. So then the 10,000 in the numerator and the 10,000 in denominator, I can just simply cancel them out, right? The reason why I'm canceling them out, or the reason why I'm actually allowed to cancel them out, is because of the fact that the same fraction, I can write it essentially as, well, this 10,000 divide by 10,000, and then basically, and then times basically the 10 that I have over here, right? And of course, you know that essentially any number divided by itself is always equal to 1. Meaning 2 divided by 2 is equal to 1. 3 divided by 3 is equal to 1. 5 divided by 5 is equal to 1. A 10 million divided by 10 million is equal to 1, and so on and so forth. Any number divided by itself is always equal to 1, right? So then basically I can again cancel the 10,000 with the 10,000, or I can just simply say that basically any number divided by itself is just simply equal to 1, and then we have essentially 1 times 10, which is equal to 10, right? So the answer essentially over here is basically a 10. So 1 lakh is 10 10,000s basically. And it makes sense, of course, because of the fact that essentially 1 lakh is 100,000 and 10 10,000s would be 100,000. So essentially that would be the same. Right? Part B of this question, we have 1 million. We have 1 million is equal to so many 100,000s. Right? Now I can write this essentially in the form essentially 1 million is equal to some number x times essentially 100,000, and then I can basically use the same relationship that exists between multiplication and division in order to solve this equation. So I take the number that I have on, which is alone on one side of the equation, so I have essentially a 1 million, and then I divide it by, I can divide by x, I can divide by this number. And we saw that, of course, when you divide by x, you're not going to be able to do anything with that essentially expression. So I'm going to divide by this, which is essentially 100,000. And that is equal to the other number, which is equal to x. So now we have the value of x, right? And so again, I can write basically x is equal to, now the 1 million, I'm going to write it as 10 times basically 100,000 and divide by essentially 100,000. And then the 100,000 I can simplify, I can cancel out in the numerator and denominator, and the answer is 10. Okay, now all of these questions that you see over here, in all cases the answer is 10, and I know that because I took a look at the solutions. So the solutions, I will essentially put them all together in essentially in the, I will essentially find some place and essentially I will essentially create a download link somewhere in the course so that you can download them, because it's probably not very easy to get to them. You would have to go to the Tiwari Academy and you might not find them. So I will essentially make them available in some way essentially in the course. You can download them, and you can see that essentially for question number 1 all the answers are 10, but of course you need to essentially, I did the first two questions here. you can go through essentially the 3 remaining ones, and just make sure that you can just get through the question basically. And for your information, essentially a lakh, just for the sake of basically as the definitions that you can use, basically a crore in the Indian system of numeration, a crore is essentially a 1,00,00,000, right? If you want to write it in the English system, you would write it as 1, and that's essentially a 10 million, right? So that's a 10 million. So a crore essentially is a 10 million, okay? And again, a lakh, as we mentioned before, 1 lakh is the same thing as essentially 100,000. These are definitions. You just simply need to remember them. There is no way to learn them or anything. You will learn them just by using them essentially, or repeatedly. After a while you will learn them. And then of course a 1 lakh is 100,000, and then a 10 lakh is 10 times 100,000, which is essentially 1 million. So you can use essentially these definitions in your solutions basically, okay? So now the next questions are, well, basically these are supposed to be written they are essentially formulated in the Indian system of numeration. Now I'm not sure if everyone is basically going to follow essentially the Indian system of numeration, so I will do essentially all of these questions myself. And I will essentially write all the numbers in both systems so that everyone is taken care of. Now we have essentially 73,75,307, and we want to write essentially write the numbers essentially and place the commas properly, right? So let's write the number in the Indian system. In the Indian system, essentially you will have basically for a lakh, basically you have essentially 2 digits over here and a comma, and another 2 digits over here and another 3 digits over here. So this is essentially the lakh part, and this is essentially the thousand part, and that's essentially the rest of your number basically, right? So when you say essentially 73 lakh, that would be 73, and then you place a comma, and then 75,000 would be 75,000, comma, and then 307 would be essentially this number over here. So that's 73,75,307. The same number basically in the English system, you would write it as 7,375,307, which is essentially 7,375,307. Okay, so that's question number 1. Question number 2, and let's keep this essentially. So you have the crore, you have the lakh, you have the thousand, and then you have the hundreds and tens and ones. So this is the crore, this over here is the lakh part, this over here is the thousand part, and then that's essentially the rest of your number. So then, for example, 99 crore would be essentially you start from here and you have 9 crore, 5 lakh. So essentially 5 lakh would be 05, for example. 41. When you say essentially 41, that means that essentially the thousand part is just simply empty. So I put 2 zeros over here, and then a 41 would be 041 basically. So that's 9 crore 5 lakh 41 basically. In the Indian system, you would write the same number as 041 and 1 comma, and then 500 another comma, and then essentially a 90 and then another comma. And that would be essentially 90,500,041. Okay. And of course, always you can check your answers over here, so you can go to the solutions. And the number is essentially this 905,00041, which is essentially the number 905 00 and then 041, which is essentially the number that we have written here, and then the same number I've written it essentially in the English system as well. Okay. Now the next question is part C, which is 7 crore 52 lakh 21,302. Make this bigger so that you can see this. So then again, basically we have 7 crore, so you will start essentially with the crore part. 7 crore 52 lakh 21,302. So that's 7 crore 52 lakh 21,302. The same number in the English system, you would write 302 1 comma, and then 221 another comma, and then a 75 and then another comma. So that's essentially 75,221,302, right? The next number that we have is part D, which is 58,423,202. So 58 million. In the English system, essentially you have essentially all of these 3 digits, another 3 digits, and then another 3 digits. So these 3 digits essentially is the million part. And then that's essentially the thousand part, that's essentially the rest of your number basically. So then the 58 million would be, you would start from here, 423,202. That's basically your number in the English system. In the Indian system, you would write this as 202, and then a 20, and then an 84, and then a 5 basically. So that's essentially 5 crore 84 lakh 20,202 basically in the Indian system basically. The next question that we have is basically 23 lakh 30,010. So for the lakh, essentially you part from this part, so essentially you have 23 lakh 30,000. So 30,000 and 10, and 10 would be 010, right? And the same number basically in the English system, 010, and then 330, and then a 2, which is essentially a 2,330,010 basically. So this number is 2,330,010 basically, and the English system is 23 lakh 30,000, 23 lakh 30,010 basically. Okay, so that's essentially your number. Now the next question that we have is essentially question number 3, which is essentially you want to insert commas suitably and write the names according to the Indian system of numeration. which I will do essentially in the next video. Thank you. Okay, so next we have questions number 3 and 4. So let's take a look at them as well. Well, we have basically, you want to insert commas and write the names according to the Indian system of numeration. So over here basically I have essentially 3 digits over all the way up to here, and then 2 digits, 2 digits, and 1 digit, right? So and I'm doing this according to the Indian system of numeration. So that's essentially the 1000, that's essentially the lakh, and that's essentially the crore. So then I have to write essentially 8 crore 75 lakhs, or essentially 75 lakh. And of course, you know that, for example, when you want to write, technically, when you want to write the 75, the number 75, you would write it as you would essentially write it as 70, and then a dash, and then a 5. So actually you need to write it this way. So I should put it essentially a dash over here. Okay. All the numbers all the way up to 100, you have to write them this way, meaning that, for example, the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 12, all the way up to 19, that's okay. You don't need a dash in those numbers. But then you have a 20, 20 again needs no dash. But then, for example, you have the number 21. The number 21, you would write it as 20 dash and a 1. And then the number 22, you have 20 and dash a 2 basically. And you just need to keep going with this pattern all the way up to 99, which is 99, and then essentially you get to 100, and then past the 100, of course, this thing is going to repeat itself, meaning that, for example, in writing a large number, essentially sometimes you come across, for example, 75, and the 75 again has to be written based on this pattern basically. Okay, so then essentially 8 crore would be, so the number essentially that we have is 8 crore 75 lakh 95,000 and 762. That's the number that we have, right? So this is the 8 crore 75 lakh 95,000, so that's again 90 dash 5, and then 1,000. 762. 60 again dash and basically a 2. So that's 8 crore 75 lakh 95,782. That's your number basically. Okay. Then again over here, for example, you have this number over here, which is 3 digits, 2 digits, and then 2 digits. So your number is essentially 85, 46, 280, 83. And then this is essentially 85 lakh 46,283, which you would write essentially 80-5, meaning 85 lakh 40 46, so 40-6,000 and 283. 283, right? So you can essentially see how these numbers are supposed to be written. And then again, essentially for this number, you have 3 digits, 2 digits, 2 digits. So you have the thousands here. So you have, let's say, essentially a 9,99,00,046, right? And that's essentially a thousand. That's the lakh, and that's the crore. So that would be 9 crore, for example, 99 lakh 46, right? The next number that we have essentially 3 digits, 2 digits, and 2 digits. So you have 9,84, 32, 701, which is essentially 9 crore, 84 lakh, 32,701. Okay. Now these numbers are supposed to be written in the according to international number of system of numeration, basically, which means that essentially you are supposed to essentially separate every digit with a comma, basically. So I put one comma over here, another comma over here. So then the number is 78,921,092. This number would be 7,452,283. This number would be 99,985,102. This number would be 48,049,831. Okay. So that's basically all that we have regarding these numbers, and I will see you in the next video with the rest of our text. Thank you. Okay, so the next thing that we have is in this text is essentially large numbers in practice. But then over here, essentially the text has talked about essentially all of these things like the centimeter, the millimeter, the meter, and the kilometer, that sort of thing, the gram, the milligram, the milliliter, the liter, and so on and so forth, which is essentially not relevant to our work here. I mean, I would have to just keep talking and talking about these. You could, of course, learn them. There is no problem. But it has no relevance to our work here. And then essentially in these books, then you would not be able even to use them for any practical purpose, basically. Later on, if we need them, which is, I suppose, never, I would say, we can essentially learn a couple of them here and there, basically. But for now, we can just simply forget about them. It's just not relevant. We cannot use them for any sort of purpose, basically. But essentially the rest of this material is pretty useful, meaning that this is actually related to learning mathematics. So it says that, for example, that the bus started its journey and reached different places with a speed of 60 kilometers per hour. The journey is shown on page 14, which is essentially this journey over here. And the journey, and find the total distance covered by the bus from A to D, find the total distance covered by the bus from D to G, the total distance covered by the bus if it starts from A, returns back to A, and then find the difference of distances from C to D and D to E, basically. So you can use essentially, you can do a little bit of calculation here, which is in and of itself useful and valuable in mathematics. Okay, so now basically what we have is, let rid of these. So then basically the speed is 60 kilometers per hour, and you want to find the total distance covered by the bus from A to D, right? Now the total distance covered by the bus from A to D would be essentially, you start essentially from A, go to B, go to C, and go to D, which is 4,170 kilometers plus 3,410 kilometers plus another 2,160 kilometers. So essentially from A to B, the bus has essentially covered the distance of this distance, and then covered this distance, and then covered this distance to get essentially to D. Now in order to calculate the total distance covered by the bus, what you will do is that you will add essentially the three distances together, right? So then what I'm going to do is that I'm going to say that the total distance of course from A to D would be essentially this calculation. It would be essentially 4,170 kilometers plus another 3,410 kilometers plus another 2,160 kilometers, right? And you note that basically that essentially the unit is over here, the kilometer, the unit is kilometer and kilometer, meaning that we are not essentially dealing with mixed units, meaning that, for example, a 21 meters plus a 26, for example, kilometers, you cannot just add the numbers together and say that, so that's a 21, that's a 26, I add the numbers together, that's a 47, so that's a 47, for example, either meters or kilometers. This 47 is neither the meter nor the kilometer, just simply not right. Because suppose that essentially the length of something, for example, the length of something is, for example, 21 centimeters. And you must be, of course, familiar with the centimeter, the unit. And the length of something else is, for example, the length of some path, for example, going from one city to another city is 25 kilometers. Now, what is essentially the sum of those two distances, basically? One of them is just 21 centimeters, which is just this large, basically. One of them is 25 kilometers, which it would take you probably at least 20 minutes to get there if you go in a car, basically, right? So the centimeter and the kilometer, these are essentially two different units, basically, and then basically as a result you cannot combine them together. It's just simply not possible, right? Now, in order to, if you actually wanted to essentially to combine these two distances, the only thing that you could do is that, for example, you could say that the essentially 25 kilometers is the same thing as essentially 25,000 meters, and a 21 centimeter is essentially a 0.21, for example, meters. Now, for now, this is a little bit advanced for where we are right now, but suppose that essentially that's 2/10 of a, that's 21/10 of 21/100th of a meter, for example. Let's say let's call this, for example, a 21/100th of a meter, right? This number essentially means something, but for now let's just take it as just any number, essentially. Doesn't matter what that means. And now that essentially I have the same basically units, now I can essentially combine these two together. Now I can say that I have 21/100th of a meter plus 25,000 essentially meters. So then I can write this as essentially 2100 plus 25,000, and then add these two numbers and write it in meter. This I can do without any problems. But in cases where, for example, you have something in centimeter and something in kilometer, of course, these are different things and you cannot combine them together, right? But then over here you can see that essentially all of these distances are in kilometers, right? Which means that essentially we can just simply add the numbers together, and then basically the whole thing would still be in kilometer. Now in order to add your numbers, you have 4,170, right? So it's always a good idea to write your numbers in such a way that everything comes in the same column basically. For example, 3,410. You see that I write the 0 below the 0, 1 below the 7, 4 below the essentially 1, and 3 below the 4 basically, right? Meaning that you're not supposed to essentially I mean, if the 1, for example, belongs in this column, you're not supposed to write it anywhere. So you just write, you're supposed to write it exactly in that column. And essentially a 2,160, and now essentially I have all of these columns. I have this column, I have this column, I have this column, and now I can essentially add all of these together. And of course you know that this is the ones place value, this is the 10, this is the 100, and this is the thousands place value. And then you can essentially add your numbers together. So essentially 0 plus 0 plus a 0 is a 0. 7 plus a 1 is 8. 8 plus a 6 is equal to 14. So you have 1 carryover. 1 plus 1 is 2. 2 plus a 4 is 6. 6 plus 1 is 7. And then 4 plus 3 is 7. 7 plus 2 is a 9. Right? So that's 9,740, and the unit is then supposed to be essentially the kilometer, right? Now, in such cases, what I meant by using the calculator, once you do your calculation, in such cases you can actually use your calculator to check your answer, to make sure that you've gotten the right answer. So 4,170 plus 3,410 plus 2,160, that's 9,740, which means that essentially we have the right answer, and we can essentially move on to the next part of this question. Now you want to know basically part 2 of this question. Part 2 of this question is basically you want to find the total distance covered by the bus from D to G. So the distance covered by the bus from D to G would be from here all the way up to here, meaning essentially going round all the way up to here. So again you have 8,140 kilometers plus 4,830 plus 2,550, and again it's the same story. You will do the addition and you will get the essentially the distance. So it's not that we have already done this essentially. Now you want to know essentially to find the difference of distances from C to D and D to E. So from C to D is this distance, and then from D to E is essentially this distance over here. And one of the distances is 8,140 and the other distance is 2,160. And you want to know the difference of them. The difference means essentially to to find the distance, the difference of two things, of course you need to do subtraction, right? You need to do subtraction. One of the distances is 8,140 kilometers, and the other distance is basically 2,160 kilometers, right? Now you can think of this problem in the form of basically, for example, there is one person over here, there is this person over here. This person has basically, for example, I don't know, 60 marbles. There is another person over here, and this person has 84 marbles, right? Now, if you want to know how many marbles this person has more than this person, or essentially how many marbles this person has less than this person, or essentially if you want to know the difference between the number of marbles that these two people have, then of course you have to do subtraction, right? And subtraction is something essentially intuitive, meaning that essentially you have these 84 marbles over here. Suppose that these are essentially 84 marbles, and essentially this person essentially has 60 marbles. Now to know the difference between essentially the number of marbles that these two people have, what I can do is that essentially I have 60 marbles over here, I have 84 marbles over here. Now to make it simpler, I'm going to change the number of marbles so that we can do actual calculation here. So let's say that this person has 2, 4, 6, 8, and 10 marbles over here. And this person has 2, 4, 6, 8, 10, and 12 marbles over here. Right? 2, 4, 6, 8, 10, and 12 marbles over here. Now to know the difference between the marbles of this person and the marbles of this person, or essentially to know how many marbles this person has more than this person, or essentially to know how many marbles this person has fewer than this person, of course the only thing that you can do is essentially to subtract, meaning that essentially you start with the larger number of marbles, which is a 12. So I have 2, 4, 6, 8, 10, and 12 marbles over here, right? And then I will subtract basically the number of the marbles that this person has. I will subtract them from these marbles. Subtract essentially means to take away. So I have essentially 2, 4, 6, 8, and 10 marbles over here. So that's essentially 2 I have taken away, 4 take away, 6 take away, 8 take away, 10 take away, and what remains is the 2. So this 2 essentially is nothing but the difference of the marbles of these two people that these two people have, right? And then this operation basically is of course called basically the subtraction. Now this is the reason why I actually said that these exercises are useful in mathematics, because you can actually learn a whole lot of things from these types of exercises. So this operation essentially is called subtraction, and if I want to essentially to write down this operation in mathematical terms, I would write essentially I started with 12 marbles, and then I took away 10 of them, meaning 12 minus 10 is equal to 2, right? And of course you have to use the you have essentially you can use essentially the model that we have over here. But then this operation, you can even do it this way. 12 minus a 10 is equal to essentially to a 2, right? And of course, you know that essentially subtraction is the opposite of addition. Meaning that, for example, I have two persons over here. One of them has 3 marbles. The other one has 2 marbles. If I want to know what is the sum of all of these marbles, meaning essentially how many marbles these two people have all together, I will put essentially all the marbles together and I can just simply count 1, 2, 3, 4, and 5. So the total number of marbles would be essentially a 5, which means that a 2 plus a 3 is equal to 5. That's addition, right? Subtraction is the opposite of addition. In addition, essentially you're putting things together. In subtraction, you're taking things away, right? And well, whenever you don't know how to subtract, basically, for example, 12 minus 10, it might be some people have problems in subtraction. It doesn't come naturally to them. But addition comes naturally to most people. Now, knowing that essentially addition and subtraction are inverse processes, you can just simply do your subtraction very easily. I'll show you essentially what I mean. So suppose that, for example, I have 12 plus 10. Let's say that this operation was essentially a 12 marbles and a 10 marbles. I put them together. I got essentially 22 marbles, basically. This operation would be a 12 plus a 10. And then to do the operation, 2 plus 0 is equal to 2. And then 1 plus 1 is equal to 2. So I have 22 marbles. This kind of operation most people can do without any problems. But essentially its subtraction seems to be kind of going in the other direction. So some people might have problems over here. Now, knowing that essentially that these two operations are basically inverse processes, what you can do is that over here, essentially to do this operation, you would say 2 minus a 0 is a 2. Or essentially 1 minus a 1 is a 0, right? And then the answer would be essentially the difference between the number of marbles of those two people is just a 2, basically, right? Now, if you cannot do it this way, meaning that if you cannot say 2 minus 0 is a 2, or essentially 1 minus 1, if the answer doesn't come to you naturally, then what you can do is that essentially to know what is 2 minus 0, basically, right? It's going to be essentially some number x, basically. Instead of saying essentially what is 2 minus 0, you could say essentially you could say that there has to be some number over here that if you add it to 0, I will get a 2. Or essentially there has to be some number over here that if you add it to 1, you will get a 1, basically. I will show essentially another example. What is, for example, 93 minus 64, for example? So this is a subtraction. Let me make it a 95, for example. That's a 95, that's a 64, so that everything is simple and easy. So what is 4 minus that? What is 5 minus 4? 5 minus 4, that means that I need to add essentially some number over here. I need to add this number to 1 so that the result becomes a 5, right? And that number essentially, you know that if you add a 1 to 4, it becomes a 5. So this number then has to be a 1, right? Or essentially, if it's not easy for you to say what is 9 minus 6, you can just simply say what is the number that I need to add to 6 to get a 9, basically. And that number would be a 3. So the difference between a 95 and a 64 would be 31. And to find that difference, I need to essentially do subtraction, basically. Okay, so that's the concept of subtraction. And now over here, essentially we can do that exact same thing, meaning that I can say that the distances are 8,140 kilometers and 2,160 kilometers, and I want to find the difference between those two distances. So I will start with the larger distance, and I write the larger, and I write my operation as 8,140. I put this first. That is essentially in kilometers, minus the second distance, which is the smaller one, and 2,160 kilometers. And the reason why I'm starting with the larger number and then subtract the smaller number from the larger number is that if I start from the smaller number, then essentially I will come up with a negative number. A negative number we have not studied yet, but it suffices to say that essentially a distance cannot be a negative number. So to find the difference between two distances, you always need to start from the larger distance and then subtract the smaller distance from the larger distance. Okay, later on when we essentially learn the negative numbers, then this becomes more clear, basically. So now that I know essentially how to do this operation, I write 8,140 minus 2,160, and I want to subtract, right? So now I could say 0 minus 0 is equal to 0, but then I could also say this 0 has to be added, essentially some number has to be added to this 0 so that I get a 0. Of course, this can only be a 0, meaning any other number that you add to 0, you will have either a 1 or a 2 or a 3 and so on and so forth, right? Now what is now 4 minus 6, for example, over here? What is 4 minus 6? Which is of course not possible, meaning that you have 4 groups of 10 over here. I have this 4 groups of 10 over here, and from these groups of 10 I want to take away 6 groups of 10. So that's not possible, right? So then what I'm going to do is that I'm going to take essentially a group of, this is the hundreds place value, so this is one group of 100, right? So the one group of 100, I will break it up, and then I will have essentially 10 groups of 100, right? Excuse me, I have essentially the one group of 100. The one group of 100, I will break it up, so I have 0 groups of 100 over here, and then when you break up essentially a group of 100, you get 10 groups of 10. So I have 10 groups of 10, and I already had 4 groups of 10 over here. So in total, I have 14 groups of 10 over here. So I write a 14 over here, and I get rid of this, right? So now basically, what this means is that I have 14 groups of 10, for example, and I want to take away 6 of them. So what is the number that I need to add to 6 to get the 14? And that number is 8. So 8 plus 6 is equal to 14. Or I could just simply say 14 minus 6 is equal to 8. Okay? Whichever one comes easier to you, you can use that one. Now again over here I have 0 groups of hundreds, and I want to take away one of them, which is again not possible. But still I have 8 groups of thousands over here. I will essentially break up one of them, which means that essentially I will be left with 7 groups of thousands, and then essentially now I have one group of thousands in buffer. I can do whatever I want to do with that. So essentially a group of thousands would be 10 groups of hundreds, right? One group of thousands would be 10 groups of hundreds. So I write the 10 groups of hundreds over here, and now I have essentially 10 groups of hundreds, and I want to take away one of them. 10 minus 1 is equal to 9. Or essentially, what is the number that I need to add to 1 to get the what is the number that I need to add to 1 to get the 10? The number would be essentially a 9. So then the difference between the two distances would be just simply, and the unit would be kilometers, of course, because essentially both the units that we started with essentially were kilometers. So that's 980 kilometers. That's the difference between essentially the two distances. Now, always essentially to make sure that you have done your calculation right, it's very easy to make mistakes. So 8,140 minus 2,160 is the same thing as 5,980, which is essentially the last step I actually forgot to do. So now I have essentially 7 groups of thousands over here, and I want to take away 2 of them. So 7 minus 2 is equal to 5, or essentially, what is the number that I have to add to 2 to get a 7? That number would be a 5. So 5 plus 2 is equal to 7. So 5,980, which is the correct number. Okay. Now the next part of this question is find out the time taken by the bus to reach from A to B, C to D, and so on and so forth. Now this is something also, it would be useful to know this, so we will talk about this as well. Okay, now on the previous page, we saw that essentially the speed of the bus is assumed to have been 60 kilometers per hour. So essentially the speed of the bus is taken, we will take it as 60 kilometers per hour. Now what is the time taken by the bus to reach, for example, from A to B? Now from A to B, essentially we'll go from here to here, which is 4,170. From A to B essentially would be 4,170 kilometers, right? Now what we want to calculate is the time taken for the bus to essentially to cover this distance. So how do we do that? Now you do that essentially based on the speed of the bus, meaning that you know that essentially the faster the bus is going, essentially whatever the distance might be, that distance is going to be covered faster in a shorter amount of time, and the slower the bus is going, whatever the distance might be, that distance is going to be covered in a longer amount of time, right? You know that essentially also from experience. Now when we say that essentially that the speed of the bus is 60 kilometers per hour, meaning if I write essentially the speed is equal to 60 kilometers per hour basically, what this means is that essentially that's 60 kilometers per 1 hour. That means that essentially in 1 hour, the bus covers a distance of 60 kilometers. If essentially, which means that then in 2 hours the bus will cover a distance of 120 kilometers. Meaning 2 hours would be twice 1 hour, and then twice 60 kilometers would be 2 times 60, which is 120 kilometers. Then in 3 hours, for example, the bus would cover a distance of 3 times 60, which is 180 kilometers, and so on and so on. That's the meaning of essentially kilometers per hour, or essentially miles per hour, or essentially the distance of the units that we use essentially for speed. Okay? Okay, so now basically if I know that the speed of the bus was 60 kilometers per hour, and we saw that essentially this is something like a proportional thing, right? Meaning that essentially in 1 hour we are covering a distance of 60 kilometers. In 2 hours, which is twice 1 hour, we will cover a distance of essentially twice 60 kilometers, which is 2 times 60 kilometers, which is essentially 120 kilometers. In 3 hours, which is essentially 3 times 1 hour, we will cover a distance of 3 times 60 kilometers, which is essentially 180 kilometers, right? So we can essentially set up a proportion with this. So then I can write essentially 60 kilometers per hour is the same thing as essentially and we have over here, and we want essentially to cover a distance of 4,170 kilometers. So I set up the proportion like this, meaning a fraction over here, an equal sign, and another fraction. That's a proportion, right? And of course, you can use a proportion only for the types of things which are proportional, meaning that, for example, this situation, as you saw, is a proportional kind of situation. So then based on this, you can actually set up a proportion, okay? So the nature of that situation has to be proportional. And then basically, I want to cover this distance, which is 4,170 kilometers. And of course, you see that in the left hand side, essentially the speed, the distance has been written in the numerator. So then again on the right hand side, I've written the distance again on the numerator. You cannot mix that up. If over here, if the distance is written, for example, in the denominator, on the right hand side, you will have to write the distance also in the denominator, okay? And so now I want to know how much time it's going to take to cover this distance based on the proportion that we had before. So the proportion that we had before was essentially in 1 hour we cover a distance of 60 kilometers. So now I want to know essentially how much time it's going to take, meaning I put an X over here, how much time it's going to take to cover a distance of 4,170 kilometers, right? Now I will dedicate an individual video, a separate video to these proportions, either later on if we need to, or essentially whenever we need to. I will do this so that essentially you understand this completely, because it's important to actually understand this. It has a lot of applications essentially in essentially wherever you go in mathematics, right? Now in order to, in a proportion, one of the things that you can do in a proportion is that you can cross multiply, meaning that essentially you set up a proportion like this, and you have one value over here, another value over here, another value over here, and another value over here, right? It's just simply like, for example, you would say essentially a 3 to 2, or essentially let's say, for example, a 3 to 6, for example. You see over here, the number 3 is half the number in the numerator, or essentially the number in the denominator is essentially twice the number in the numerator, meaning that if I multiply the numerator by 2, I'll get to the denominator, right? 2 times 3 is equal to 6. So that's the same thing as basically essentially 1 to half, basically, right? Because this is the same proportion essentially. Again, a 1 when you multiply it by 2, you'll get a 2. A 3 when you multiply it by 2, you'll get a 6 basically. And you can just keep going with this. For example, a 4 divided by 8. Again, a 4 when you multiply it by 2 is equal to 8. And you can just keep going with this. But I'm just simply going to take the first two parts, right? Now this is of course a proportion, and this is a valid proportion. Now in a valid proportion like this, you can always cross multiply, meaning that you can essentially multiply these two together, and then you can multiply these two together. These two essentially multiplications are going to have the same value, meaning that if I multiply essentially these two together, that would be 3 times 2, and that should be equal to essentially 6 times 1, right? And of course you know that 3 times 2 is equal to 6, 6 times 1 is equal to 6, and this property always exists essentially in a proportion, right? So the same thing basically you can always do it. We can do it over here in order to find the value of x basically. So then basically I could cross multiply, meaning that I can take this value, multiply it by this number, and then I can take this value over here, multiply it by this number, right? So 60 kilometers times basically x is supposed to be equal to 4,170 kilometers times essentially 1 hour, right? And again you can see that basically that we have essentially an equation like the situation that we had essentially with 15 is equal to 3 divided by 3 times 5, and then you can write 15 divided by this number is equal to that. The way that exactly we essentially solved equations, we can use the same strategy in order to solve this equation. So then I'm going to say that essentially this whole number, which is written on the one side of the equation, if I take the number which is essentially alone on the one side of the equation, I can say that 4,170 kilometers times basically 1 hour, and then divide that by essentially any of these two numbers. I'm going to divide by 6 kilometers so that we can actually do some calculation here. This is supposed to be equal to this x basically, based on what we said about equations. Now we have essentially a unit over here which is kilometers, and kilometer I'm going to cancel out together. Essentially one of them is in the numerator, the other one is in the denominator, and they are essentially both units. They are both essentially the same unit, so I'm going to cancel them out. And so then basically the value of x would be equal to 1 times this value divided by this value. So that's 4,170 divided by 6, and the unit would be hours, right? So that means that it's going to take essentially 4,170 divided by 6 hours to essentially to cover this distance of 4,170 kilometers. Now this value over here, you can of course you can do long division, that's okay, but then you can calculate it on a calculator as well, and that would be essentially 695 hours basically. So this should be essentially 695 hours. Now you just simply need to make sure that your answer also makes sense or not. And to me this answer doesn't make much sense because it's way too large essentially, the answer. Meaning that essentially over here we said that we had a speed of 60 kilometers per hour. So 60 kilometers per hour, that means essentially in 1 hour we cover a distance of 60 kilometers. And we wanted to cover this distance of basically 4,170 kilometers, right? Now if I essentially cover a distance of 60 kilometers essentially in 1 hour, in 695 hours, I'm going to cover a distance of 60 times essentially something around 700. So essentially then essentially in 695 hours we will cover a distance of basically 60 is essentially for 1 hour. In 695 hours, that would be 60 times 695 essentially, and that would be essentially in kilometers. So I repeat this: if you cover a distance of, if you have a speed of essentially 60 kilometers per hour essentially, that means essentially in 1 hour you cover a distance of 60 kilometers. Now we have calculated essentially 695 hours. So then in 695 hours basically we will cover a distance of essentially 60 times essentially 695 kilometers. Now 60 times 695, that's the same thing as 41,700, which is way too large a number. We wanted to cover a distance of 4,170, but over here the calculator is telling me that in this something around 700 hours we will cover a distance of around 41,700 essentially kilometers, which means that essentially I have actually made a mistake over here. And then the mistake that I have made is that over here I have written this thing. I was actually supposed to divide by 60, but then I have divided by 6. That's why the number has turned out to be so large basically, and it must have been somewhere over here. So when you do the cross multiplication over here, this is essentially instead of a 60, I have written essentially a 6 kilometers instead of 60 kilometers. So now if we correct this mistake, we should get essentially an answer which is essentially 69.5 hours basically. Okay, we should get an answer which is 69.5 hours basically. We will see that. So now let's do the cross multiplication again. The cross multiplication, essentially you will multiply essentially what you have here by what you have over here. So we will write essentially 60 kilometers times x is the same thing as and then you will multiply essentially these two numbers together, this number and this number. So that's essentially 1 hour times 4,170 kilometers, right? And now this should give us essentially the right answer. Now again essentially we have an equation. To solve this equation, I'll take this number, which is essentially the alone number on the one side of the equation, and essentially write it on the numerator. So I write this as essentially 1 hour times 4,170 kilometers, and then I divide it by this number so that I can do some calculation. So that's 60 kilometers, and I had written over here a 6 kilometer, which was the reason why the number essentially got so large basically, and that's supposed to be equal to x basically, right? Again, essentially the two units, kilometer and kilometer, I will cancel out, and then x is supposed to be equal to this 1 times anything is just the same number, so you don't have to worry about 1 when you when you're doing multiplication. And so I have 4170, and then divide by 60, and then the unit over here is essentially hour. You're not supposed to forget the unit. Very important. Otherwise, you will just simply get confused. You don't know what you have calculated. So now if I do this calculation over here, 4170, and if I divide that by 60, I'll have 69.5. I have 69.5 hours basically. Now again we will check whether the answer that we have gotten makes sense or not. So now I will essentially, in a separate video, I will show you essentially what is the meaning of 69.5, because we have essentially worked on the decimal number system, but these decimal numbers, we have not essentially talked about them. Now, since we have to use them, we will essentially talk about them in a separate video. But it suffices to say that for now, that 69.5 is very close to, essentially very close to a 70, right? So the time that we have calculated is very close to 70 hours. And the speed that we had was 60 kilometers per hour. So if the speed is 60 kilometers per hour of the bus, what this means is that essentially in 1 hour the bus covers a distance of 60 kilometers. So then in 70 hours the bus is going to cover 70 times the same distance. So then 70 times essentially 60 kilometers is going to be, what is that? So 7 times 6 is equal to 42, and then we have 2 zeros over here, so that's 4200 kilometers, which is essentially the distance that we had over here, 4170 and 4000, that's 4170 and 4200. So now that the answer is correct and everything is without any problems. Now there were two things that now essentially two concepts that we need to discuss. First, I will discuss essentially decimal numbers. In the future videos somewhere I will discuss decimal numbers, and secondly I will discuss essentially proportions in two separate videos. We will take care of these two basically. So thank you for watching this video, and I'll see you in the next video with the rest of these exercises. Thank you. Okay, so hello and welcome back. Now in the previous video we talked about essentially question number 1. Try these, which was essentially number 1, and we answered essentially all of the essentially the part 5 of this question as well, but I did part A of essentially part 5, but I didn't do part B, C, and D. Now in order to essentially to practice what you learned in the previous video, you can do at least probably 2 of these, for example part B or C, or essentially all of them. If you find the time, do B, C, and D essentially. And if you have any problems with this, you're welcome to ask, and I will essentially go through these questions if need be. Okay. Now secondly, we have basically question number 2, which is, and I'm essentially going through these problems because as you saw, for example, in the previous video, we saw that essentially there is these different concepts that need to be essentially added to this chapter. For example, decimal numbers, or basically proportions. So these are all very important things that of course need to be that essentially that we need that will essentially know about them as we go through essentially these questions. Now question number 2 is Rahman's shop, and here essentially we have these different items, like for example apples, oranges, combs, toothbrushes, pencils, notebooks, soap cakes, and so on and so forth. And here you see that essentially here the price has been written, and this symbol over here is essentially the symbol for rupees, which is the currency unit in India. Okay, so instead of writing rupees in India, you would write it essentially as rupees, as this symbol over here. Okay, now when you say essentially 40 rupees per kilogram, that's again essentially one of those essentially unit, and you need to understand essentially what that means. So first of all, this thing over here is rupees. In India you would write it this way, because essentially in the Hindi language, a re essentially is written this way. This is a re in Hindi. Okay, for example, that's a re, and so they have essentially added this thing to the re, and it's become essentially the rupees basically. And secondly basically we have for example 40 rupees per kilogram. So that's rupees 40 per kilogram. So this is essentially a price. That's the same thing as saying essentially 40 rupees per essentially per kilogram, which is essentially the same thing as rupees 40 per 1 kilogram. That means that essentially for the price of the apples basically, we will charge basically for 1 kilogram we will charge essentially 40 rupees. For 2 kilograms, essentially for twice 1 kilogram, which is 2 kilograms, then we will charge essentially twice 40 rupees, which is 80 rupees. For 3 times, essentially for 3 times 1 kilogram, essentially for 3 kilograms, or essentially 3 times 1 kilogram, we will charge essentially 3 times 40 rupees, which is 120 rupees, and so on and so forth. So as you can see, essentially all of these essentially such units are always proportion. You can form essentially proportions using essentially these units, right? And the same goes essentially for 30 rupees per kilogram, 3 rupees for 1. So this 3 rupees for 1 means 3 rupees for essentially or per 1 comb. 10 rupees for 1 means 10 rupees per 1 toothbrush, and so on and so forth, right? And so this was essentially the unit price for essentially all the items that Rahman had in his shop. And then the sales during the last year these are the statistics for the sales in the last year, which is essentially apples 2,457 kilograms, which means that he sold so much apple basically, 2,457 kilograms. He sold essentially 3,004 kilograms of oranges, so many combs, so many toothbrushes, and so on and so forth, right? Now we want to answer this question based on the information that I have here. We want to answer essentially the weight of the apple. Essentially, can you find the total weight of apples and oranges Rahman sold last year? So he sold essentially so much apple last year, and so much oranges last year. So the weight of the weight of the apples was, let me write this on our sheet here. So then basically the weight of the apples, essentially the total weight of the apples that he sold was essentially, apples would be this, so 2,457 kilograms, right? And then the total weight of oranges that he sold was 3,004 kilograms. So then in total, basically, what was the total weight of essentially apples and oranges that he sold? So now in order to find essentially the total weight, you have to essentially take the weight of the apples, which was 2,457 kilograms, and then the weight of the oranges, which was 3,004 kilograms, and then we add them together, right? So then the total weight would be 2,457 kilograms plus another essentially 3,004 kilograms. This is in kilograms and this is in kilograms. So when you add them together, 7 plus 4 is equal to 11, so you have 1 carryover. 1 plus 5 is equal to 6, and then we have a 4 over here and we have a 5 over here. So then the total weight is 5,461 kilograms apples and oranges together, right? And if you do this on a calculator again, you have 2,457 plus 3,004, that's basically 5,461 kilograms in total, right? So that's about essentially the first part of the question. Now the second part of the question is basically, can you find the total money Rahman got by selling apples? So he sold basically in total, he sold essentially 2,457 kilograms of apples, and the unit price for apples was essentially rupees 40 per kilogram. That was the unit price for apples. So then essentially to find essentially the total money Rahman got by selling essentially all of these apples, how do you find that? To find that, basically again you can use proportions, or if you can still use your logic in order to find the answer. Meaning that essentially you could argue that essentially the unit price for apples is essentially 40 rupees per kilogram. Now if we sell essentially 2,005, now let's forget about this number for now. Let's say that the unit price for apples is 40 rupees per kilogram. Now which means that essentially if I sell 1 kilogram, that would be essentially 40 rupees. If I sell twice 1 kilogram, which is 2 kilograms for example, that would be twice essentially 40 rupees, which is 80 rupees. If I sell, for example, 3 times 3 kilograms, which is 3 times 1 kilogram, then the money that I will get is essentially 3 times 40 rupees, which is 120 rupees, and so on and so forth. And this is the case essentially because of the fact that this is proportional. If for 1 kilogram if you pay 40 rupees, for 2 kilograms you will pay twice essentially 40 rupees. For 3 kilograms you will pay 3 times 40 rupees, and so on and so forth. So which means that essentially if if the unit price is 40 rupees per kilogram, then if I sell, for example, 3 kilograms, it's going to be 3 times 40, which is 120. And therefore, if I basically sell 2,457 kilograms, then the amount of money that I will obtain from this transaction is going to be essentially 2,457 times 40 times 40 essentially, and then the price is going to be in rupees, right? So then the total amount of money would be equal to essentially 2,457, which is essentially the total amount of apples that he sold essentially last year in kilograms, times basically 40 in rupees, and then you can essentially do this calculation and get the answer, right? Now you can see that this, of course, if you can argue essentially, and if you can use your logic this way, this is essentially you can essentially calculate it this way without any problems, and there is no problem in that. But then essentially this has the problem that you might essentially there are situations that are in which the context is a little bit confusing, and if the context is confusing, then you might actually confuse the units. And so, for example, you see here that here basically you have to take this number, for example 2,457, then you will have to ignore the unit kilogram over here, then you will have to multiply the number by this number over here, again you will have to ignore this unit over here, and then take this unit and use this unit for this calculation, right? And so it's possible that you might actually make mistakes essentially in this calculation. So if you think that you might actually make mistakes in the calculation, then what you can do is that you can say that, okay, so the price of the apples is essentially, as we saw over here, was 40 rupees per kilogram. The price of the apples was 40 rupees per essentially 1 kilogram, right? That's essentially the meaning of that's essentially the meaning of what you read over here, right? And then you can essentially form a proportion and write over here, this is the same thing as now essentially what was the total amount of apples that we sold. It's 2,457 kilogram, and you see that kilogram has been written in the denominator, so I will write 2,457 kilograms in the denominator, right? Not in the numerator. If you essentially misplace this number, meaning that if you write it in the numerator, then the whole thing essentially will just simply not work. And now I want to know essentially the total money that Rahman got by selling these apples. So the money is in the numerator, is in rupees. So I put an X over here, which means that this X I want to calculate it, right? So now it's a proportion, and as we saw before, in a proportion you can cross multiply, meaning that you can essentially take this amount, this 40 rupees, and essentially cross multiply this way, and then you can essentially take this X and this 1 kilogram and then cross multiply this way, meaning that essentially if you have, whenever you have a fraction, you have some amount, something over here, something over here, and something over here, then what you will do is that you will cross multiply this way and cross multiply this way, meaning that essentially if you have A over B is equal to C over D, for example, it's a valid proportion, and A, B, C, and D are essentially some numbers. Then if I cross multiply A and D, I will write A times D and then equal to, because of this equal sign, and then cross multiply B and C, that's B times C. So that's essentially what you do in a proportion, right? So then I will essentially simply take these amounts and then cross multiply. I will write 40 and then rupees, and you can see that here I don't have to worry about units and things like that. The unit essentially automatically comes with the number because it's just simply written over here. And then I multiply this by 2,457 kilograms, which is this thing over here, is equal to X times 1 kilogram, right? Now I have a simple equation, and the equation I can solve, and there is no way that I can make any mistakes. Now you see in this equation there is one side of the equation where there is no x. There is one side of the equation where there is your x. The side of the equation where there is no x, that is the side which I called essentially the number is alone over there, is alone on one side of the equation. So this is supposed then to become the numerator, and so I will write it as essentially 40 rupees times basically 2,457 kilograms, and then I have to divide this by any of these two numbers. I could divide by x, I could divide by essentially 1 kilogram, right? If I divide by x, you know that essentially the thing is not going to work because I will not be able to do any sort of calculation. So I will essentially divide by the kilogram. So by 1 kilogram is equal to the other number, which happens to be x here. So now we have calculated the value of x. And the good thing essentially then again about this system is that then basically the units that you're not going to need anymore, they're going to be cancelled out automatically. Because you see over here you have 40 rupees here, you have multiplication, and then 2,457 kilograms. This number, and this multiplication sign, and then you have this number over here with along with essentially all the units basically. So this, and whenever you have this kind of situation where you have essentially, for example, one number times another number divided by some other number, you can always simplify things as much as you want, right? Now if I want to explain why that is, it gets a little bit complicated. It gets into algebra. So for now I cannot really explain why that is so, but whenever you have essentially a division, so this is your division sign, and in the numerator essentially you have a bunch of numbers multiplied together. In the denominator you have a bunch of numbers multiplied together. And of course this doesn't work if you have addition and subtraction. That doesn't work. But if essentially there is, and only in case of multiplication, when there is a bunch of numbers in the numerator multiplied together, a bunch of numbers in the denominator multiplied together, whatever you see essentially that from the numerator and denominator, whatever can be cancelled out, you can just simply cancel them out. Meaning that, for example, the kilogram can be cancelled out with the kilogram, and what remains here is just a 1, which is not important because you're dividing by 1, and anything divided by 1 remains the same basically. So here now the value of x essentially becomes 40, which is this number. Of course, you have to be careful not to miss anything. Okay, sometimes essentially there is something over here, you just don't see it, you don't read it, and then you will miss it. So you have a 40 times this number, which is essentially 2,457, and the unit is rupees, right? So then basically, if you do this calculation now, I used to do all of these calculations by hand, but that's going to waste your time. But eventually, I mean, you could, for example, when I discuss something over here in these exercises, you could take a look at the video and understand essentially how to solve the problem, and then you can do it one more time yourself, essentially by hand, so as to learn essentially all the steps, so that, and then the calculations you can also do by hand, so that you learn how to essentially do calculation manually. All of these are important. You need to do this as essentially depending on the amount of time that you have essentially at your disposal, of course. Okay, so then basically if I say basically 40 times basically 2,457, that's the same thing as 98,280. So that means that as a result of selling these 2,457 kilograms of apple, Rahman got last year, he got 98,280 rupees. Okay, so that's basically how you would solve this problem. And now let me see essentially what we have here. So that's the total amount of money that Rahman got by selling, essentially total money Rahman got by selling apples, basically, for example, right? Now again over here, for example, can you find the total money Rahman got by selling apples and oranges together? So this is again simple. You will do the exact same thing that we did here. You will calculate essentially the amount of money that he got by selling essentially apples and oranges. So essentially for the apples we have already calculated here, and then you will do the exact same thing for oranges, meaning that essentially the unit price for oranges is over here, and he sold essentially 3,004 kilograms of oranges. And then essentially you'll go through this exact calculation for oranges, and then at the end of that calculation you will come up with some number like this, which is the total amount of money that he got as a result of essentially selling the oranges. Now essentially you have this number and some other number over here, and then when you add those numbers together, you will get essentially the total amount of money that he got for selling apples and oranges, right? Now the next part of this question is make a table showing how much money Rahman received from selling each item. Arrange the entries of amount of money received in descending order and find the item which brought him the highest amount. How much is this amount? So you can essentially do all of this. You can essentially make a table and essentially do this calculation for each and every item essentially on this list. Apples, oranges, cones, and everything. You can calculate that. You can calculate essentially the total amount of money that he got as a result of selling each and every one of these items, and then write down those numbers essentially in your table. And then, well, you can arrange the entries of amount of money in descending order, meaning essentially starting from the largest amount of money to the least amount of money, and then of course, and then you can also essentially find the item that brought him the highest amount of money, and then specify that amount as well. Okay, so these are all the things that now I expect you to be able to do. And if there is any problems anywhere, please ask. I will basically try to answer the question. So now the next part of this question is now this is the end of the try these part, right? This is the end of this was try these, and we came all the way up to the end of this try these part. In the next videos there is usually very useful things in these examples as well. We'll have to go through each and every one of them. So I will see you in the next video with the examples. Thank you.